we're back with our classes on alcohol, phenols and ethers. We have finished the method of preparation of alcohol and phenol. So let us revise back what we needed to do. We said for aliphatic alcohols, the method of preparations are, for aliphatic alcohols, the method of preparation is hydration of alkene, hydroboration of alkene, reduction of aldehyde, ketone, carboxylic acid and esters, and reaction of Grignard's reagent. Grignard's reagent, if they react with formaldehyde, it gives you primary alcohol. If it reacts with any other aldehyde other than formaldehyde, it gives secondary alcohol. And when it reacts with ketones, it gives tertiary alcohol. These are the methods of preparation of aliphatic alcohols. Hydration of alkene, hydroboration of alkene. Hydroboration means you react it with diborane. Okay. Then reduction of aldehyde, ketone, carboxylic acid and esters and Grignard's reagent. Now for the preparation of phenols. We said from haloarenes. Next was with benzene sulfonic acid. Next was from diazonium salt. And last one from cumene. I think only these many methods we studied for preparation of phenol. Now write properties, physical properties of alcohols and phenols. You have to write physical properties of alcohols and phenols. The first thing, boiling point. We have to talk about, okay, before I start, always understand the chemical properties or physical properties of alcohol are mainly due to their OH group. So you have two kinds of group here, one the alkyl group and the OH group, one the aryl group and the OH group. So the properties of alcohols and phenols, if they vary, it is because of the alkyl group and the aryl group. The chemical properties of alcohol, that is either aliphatic alcohol or phenol, are largely dependent on the OH group. Now before that, before I get into the class, I have sent you notes in the group of all the three chapters, that is alcohol, phenols, ethers, aldehyde, ketones, carboxylic acid and amines. Those notes are not my notes. Those are the notes which I have from some previous year student or someone who gave me. If you don't follow my classes every time and you just read through the notes, there may be certain key points which you will miss. So make sure whenever you see the class, you write along with the class and make your notes, because that is important. You can keep those notes as reference. Now in the second book. In the second book, we have done chemistry in everyday life, polymers and biomolecules. I am not talking from the CBSE point of view because certain chapters have been deleted. I have also done haloalkanes and haloarenes. I am doing the fifth chapter, which is alcohols, phenols, ethers. I am left with only two chapters from this book, which is aldehyde, ketones, carboxylic acid and amines. So two chapters from second book only are left. We are doing the fifth chapter. Okay. Now coming to the first book. In the first book, chemical kinetics has been done. We had done metallurgy, but I have stopped it at some juncture because we are just waiting for the reduction of PU board syllabus also. As per the CBSE board, the chapter of metallurgy has been deleted. We have done P block group 18. We were doing group 17. What I will do is, as soon as ma'am finishes her 4 chapters, you know Nandita ma'am is doing her 4 chapters. After that, I will send you a video of P block notes which you will follow, and the rest of the chapters I will teach. Maybe by December end, we should be done with most of our chapters. Okay? I am not giving you tests in any of the chapters because the way to conduct the test and to correct it becomes difficult. So what I will do is, on Thursday, from next week onwards, Thursdays will be our test day, because Thursdays you will write in the night the test at a stipulated period of time, and Friday when you are coming to attend math class, you will hand over your sheet papers to me. So Thursday will be considered as your test day for chemistry. Okay, so this is how our plan of action will go. You may start from anywhere the test, whether it is your school exams going on or not. You are supposed to write a test of mine, and it will be a subjective test, not an objective test. There will be separate paper given for both CBSE and state. So you will have to open that paper code and write at that particular period of time. Okay? Sure. Now, from what we were doing, we have to study physical properties. Chemical properties are mainly because of OH group. The variation in the properties will be because of the alkyl group in aromatic alcohols and the aryl groups in phenol. Right? Our first physical point or physical property, which is what? Boiling point. Okay? You know that in most of the compounds, if they show intermolecular hydrogen bonding, there is clustering of molecules, and due to clustering of molecules, they will have high boiling point. So please write alcohols, or in alcohol, the boiling point increases with increase in number of carbon atoms. The boiling point increases with increase in number of carbon atoms. What does it mean? Methanol will have low boiling point when compared to ethanol, when compared to propanol. Am I correct? Am I wrong? Am I correct? Am I wrong? See the symbol. I am telling what wrong it is. How it should be? It should be like this. What did I say? It increases with increasing boiling point. So propanol will have the largest boiling point and methanol will have the least boiling point. What may be the reason? Because of increasing? I told you, the boiling point increases with increase in number of carbon atom. When the number of carbon atom increases, what increases? See, you should learn now, after studying so many chapters, you should be able to understand that boiling point increases due to intermolecular hydrogen bonding or due to van der Waals forces of attraction. More the number of carbon atoms, more will be the van der Waals forces of attraction. So please write, this is because of, this is because of increase in, this is because of increase in van der Waals forces. Is it clear now? So the first point in the boiling point of alcohols, the boiling point of alcohol increases with increase in number of carbon atoms. This happens because of increase in van der Waals forces of attraction. Right, second point, boiling point decreases with increase in branching. Boiling point decreases with increase in branching. Why? This we studied even in hallucinations. Surface area, and you cannot just say surface area. What happens?
Surface area increases.
With branching, surface area increases. So what decreases?
Boiling point.
Why?
You don't form lattice.
Gases form lattice. Gases form lattice. All our initial compounds are either liquids or gases. Have you seen an alcohol which is solid? Then where is crystalline lattice? What should be? Just now I said, what is more? Van der Waals forces. What happens when the surface area increases? It's simple again. Please write. This is because with an increase in surface area, with an increase in surface area, there is decrease in van der Waals forces. With an increase in surface area, there is decrease in van der Waals forces. This you have studied last year in thermodynamics. Okay, so always understand two things about alcohol's first physical property, boiling point. Boiling point increases with increase in number of carbon atom, because as the surface area increases, number of carbon atom increases. What happens? Van der Waals forces
Decreases.
This is what is the problem. As you have more number of carbon atom, the mass increases. So the van der Waals forces increase. When you branch it, the surface area increases. When the surface area increases, van der Waals forces decreases. Okay. Now write in phenols. And alcohols, the boiling point is generally higher than hydrocarbons, ethers, haloalkanes, and haloamines of comparable molecular masses. Okay, now what does this term mean? See, if I take an alcohol or phenol which has nearly the same molecular mass or which has nearly the same kind of carbon atoms, then you will find that the boiling point of alcohol will be more than the rest of the compounds. Let us consider, I take C2H5OH and I take the first ether CH3OCH3. Both have a molecular formula what? C2H6O. But the boiling point of alcohol is much more than the boiling point of ether. What is the reason? The reason is these alcohols show what? They show what they show? Intermolecular hydrogen bonding. Due to intermolecular hydrogen bonding, there is clustering of molecule, and due to clustering of molecule, there are more number of bonds to be broken, and hence more will be the boiling point. So please write, even in case of phenols, if I take C6H5OH, this H will now attract this is called as what? Intermolecular hydrogen bonding. First draw these two structures and then write the answer. This is intermolecular hydrogen bonding in aliphatic alcohols. This is intermolecular hydrogen bonding in phenols. Please draw and then write. When does NPS have test chemistry? First week or first date?
First week.
Not dates, not yet told. But you have all understood the chapter of aldehyde ketones carboxylic acid. The smile speaks a lot. Okay, done? Now write. The boiling point of alcohol is more than that of any other than rest of the compounds. Boiling point of alcohol is more hydrocarbons, haloalkanes and haloarenes. Haloarenes due to intermolecular hydrogen bonding. Due to intermolecular hydrogen bonding shown by alcohols and phenols. Shown by alcohols and phenols. This is a 2-mark question. See, always understand, boiling point of ethanol is more than methoxymethane. This is because it shows intermolecular hydrogen bonding, whereas in ethers it does not show intermolecular hydrogen bonding. There is absence of intermolecular hydrogen bonding. There is presence of intermolecular hydrogen bonding. Alright, so understand first, in boiling point we studied 3 things. First point was boiling point increases with increase in molecular mass because the van der Waals forces increase with increase in molecular mass. Second, boiling point decreases with branching because as the surface area increases, van der Waals forces decreases. Third, we also studied that in general if you look, the boiling point of alcohol and phenols is more than that of other hydrocarbons or ethers or haloalkanes or haloarenes. This is because they show intermolecular hydrogen bonding, whereas all the other class of compounds which we said, such as hydrocarbon, ethers, haloalkanes and haloarenes, do not show intermolecular hydrogen bonding. Alright, next heading called solubility. We all know that generally when alcohol is consumed, it is consumed along with water. Yes or no? And when we talk about the alcohol, what we consume or what people consume, it is which alcohol? Ethanol. So what we write, lower alcohols are generally soluble in water in all proportions due to what? Due to intermolecular hydrogen bonding with water. Right? Lower alcohols are soluble in water due to their ability to form hydrogen bonds with water. Due to their ability to form hydrogen bonds with water. Please write. As the alkyl group or as the size of the alkyl or aryl group increases, as the size of the alkyl group or aryl group increases, the solubility decreases. Why does the solubility decrease? The answer to it is larger alkyl groups are what in nature? Are hydrophobic in nature. So solubility clear? Lower alkyl groups are easily soluble in water because they can easily form intermolecular hydrogen bonding. As the size of the alkyl group increases, the solubility decreases because the larger alkyl groups are what? Hydrophobic in nature. See, in organic chemistry, don't try to give very fake answers. If you give fake answers and bluff, you will lose marks. Your answer should be very small, but it should be to the point. Okay, now write third point, even phenols are soluble in water as they can form intermolecular hydrogen bonds with water. As they can form intermolecular hydrogen bonds with water. So this this is all about what? Physical properties of alcohol. Now we will talk about what? Chemical properties of alcohol. So we will talk about what now? Chemical properties of alcohol. When you are actually studying chemical properties of alcohol, you generally study the properties under two heads. What are the two heads? See, there should be, first one, there should be a cleavage of O and H. I have ROH, this bond should break. So there are reactions involving the breakage of OH bond. And what will be the second point? When there is a cleavage of RO bond, the entire OH group only will be replaced. So write first heading, reactions involving cleavage of OH bond. Reactions involving the cleavage of OH bond. And second, see, R basically is what? Carbon. So reaction involving the cleavage of CO bond. Reaction involving the cleavage of COH bond. Clear? So basically, either the OH bond will break or either what bond will break? COH. And this OH will be completely removed as a nucleophile and it will be substituted. So please open your textbook now to page 326. Open your textbook to page number 326. I don't have one here. Okay, page number 326. See, you at the where it starts as alcohols, chemical reactions. I don't know, 326 in my page. I am actually looking at this part. I'll just check which page. Chemical reactions.
326. Chemical reactions.
334.
I don't think it is 334. Just show. One second. Yeah, 334. Okay. So we are looking at page number 334. Okay. Why am I asking you to read this part? Is it shows you the versatile nature of alcohol. Sometimes a question of versatile compounds. Comment. Please write there, all of you, the question. Alcohols are versatile compounds. Comment. What will you comment there? That they can act as both electrophile as well as nucleophile. How it can act as electrophile? See, if I actually take alcohols as electrophile, you will find that you can see the second reaction. All protonated alcohols act as electrophiles. What do you mean by protonated alcohol? You know, if I write RCH2OH, this is a simple primary alcohol which I have taken. This, when it reacts with H plus, what it does? This H will come and add here because it has got what? One lone pair electron. So it forms what? RCH2OH2 and there will be a positive charge. So it behaves as what? Electrophile. So protonated alcohols behave as electrophile. In general, if I write ROH, this is oxygen is what center? Electron with center. So it behaves as what? Nucleophile. So alcohols can act as nucleophile and protonated alcohols can act as electrophile. Please write. Alcohols are electron-rich species. First point. Alcohols are electron-rich species due to the presence of two lone pair electrons on the oxygen atom. the presence of two lone pair electrons on the oxygen atom, and hence they act as nucleophiles. Please write. Next point, you can write the equation there which is given, that R OH, you have to show your two lone pair electrons. This unit is connected to the carbon atom. Which carbon it is? A positive carbon, because it does not have a one single bond. It's a carbocation. It forms what? It forms an intermediate compound where you will have R, you will have O, one lone pair electron, and the C will come and add. So this is an intermediate compound that takes place. Okay. Finally, what happens? This H plus will be removed and it will form R, O, C, and this bond will be formed and H plus will be removed. So here it acts as what? Nucleophile. Right. Protonated, second point, protonated alcohols behave as electrophiles. Protonated alcohols behave as electrophiles. Write just this reaction. This reaction is right. Protonated alcohols behave as electrophile. So now you know why alcohols are versatile in nature. Alcohols are versatile in nature because they can act as both electrophile as well as nucleophile. They can, in general, they act as a nucleophile because they are hard electron rich and there are two lone pair electrons on the oxygen atom. But a protonated alcohol or alcohol in acidic medium basically will start behaving like a electrophile. Now write reactions involving cleavage of OH bond. Reactions involving cleavage of OH bond. Reactions involving cleavage of OH bond. Right? First reaction. Reaction with metals. Reaction with metals. Okay, now in general, any metal when it reacts with acid, what does it give? Tenthalu odidira, acid bases and salts. See, I'll just confirm first. What am I talking about? Reaction with metals. Isn't it? See, what do we study in metals? We study that any metal, when it reacts with an acid, it forms salt and liberates what? Hydrogen gas. This we have studied. And we have studied that this hydrogen gas can be tested by bringing the burning splinter near the mouth of the test tube, which goes off with a pop sound. This is how we have studied that any metal, when it reacts with an acid, it forms salt and liberates what? Hydrogen gas. If I take a metal, let us take, I take Na and I react it with alcohol, C2H5OH, and I get what? C2H5ONA plus H2. Okay, I get 2C2H5ONA plus H2. This shows what? Alcohols are acidic in nature. They react with metal to liberate, to form salt and liberate hydrogen gas. So when any metal reacts with acid, it forms salt and liberates hydrogen gas. The same reaction is followed by alcohol. So alcohols are also what in nature? Acidic in nature. The reaction of metal acidity of alcohol of alcohols and phenols. So what are we trying to prove? We are trying to prove you that alcohols and phenols are what in nature? Acidic in nature. In Baridi. Reaction with metals in the Baridi. Alcohols and phenols react with metals such as sodium, potassium and aluminium to give alkoxide and liberate hydrogen gas. Hydrogen gas. Okay, so our first reaction which we will do now will be a general reaction. Let us write ROH, that is C2H5OH plus 2Na gives 2RONA plus H2. This is called as what? Sodium alkoxide. If I take the alkyl group as C2H5, it becomes sodium ethoxide. Let us take a reaction. I will take with CH3OH, 2CH3OH plus 2Na gives what? 2CH3ONA plus H2. Name of the compound? Sodium methoxide. And it liberates what? Hydrogen gas. Right? Now the second equation, one with sodium is over. Now we will write with aluminium. This equation is very important. It is a reaction of tertiary butyl alcohol with aluminium. So let us now draw first tertiary butyl alcohol. Tertiary butyl alcohol, I should take what carbon atom? Tertiary carbon atom. What is a tertiary carbon atom? Which has three different alkyl groups attached to the carbon atom. This is what? Tertiary butyl alcohol. It reacts with aluminium. Okay. Now, understand here, aluminium has a valency 3. What kind of a compound will it form? This H has to be removed. Then, this has to be both sides 3. Then only it will form. So what will be the name of the compound? And what will be the formula of the compound? See, air has a valency 3. So C, CH3, 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 O, whole thrice, Al. This is called as what? Aluminium tertiary butoxide. What it will be called as? Aluminium tertiary butoxide. Plus what should be removed? Hydrogen. Balance this equation. It's 3. From where we remove hydrogen? H2. This has to be written as 6. Then this will become 2. And then you will get 3H2.
2A.
So please write the equation. This equation is very important. Please write equation of tertiary butyl alcohol with aluminium. Tertiary butyl alcohol, when it reacts with aluminium, it forms aluminium tertiary butoxide. Please write the name of the compound below it. It is what? Aluminium tertiary butoxide. Tertiary butoxide, and hydrogen is liberated. Okay. Now we will take reaction with phenol. We will take reaction with phenol. With will take phenol, which is C6H5OH, and I react it with Na. So it forms what? 2C6H5ONA plus H2. This is called as what? Sodium phenoxide. Sodium phenoxide plus H2. How many molecules? 2 molecules. Phenol with sodium forms sodium phenoxide and hydrogen. Done? Okay, this was it what? With metal. You can put a small star and write phenol also reacts with NaOH. NaOH is what? A base or an alkali. It reacts with NaOH to form what? Sodium phenoxide and water. So please understand here, this also shows what? Acidic nature of phenol. If phenol is acid, this is base, this forms salt and water. This reaction is called as what? Neutralization reaction. So when I am talking about acidic nature of alcohols and phenols, I will say these reactions are important to show that alcohols or phenols are acidic in nature. Whenever alcohols and phenols react with metal, they form salt and liberate hydrogen gas, just like any other mineral acid like HCl, H2SO4, HNO3, etc. We also see that phenols react with sodium hydroxide to form salt and water. This shows that phenols behave as an acid. I am not going to continue here on acidity of alcohols and phenols. That we will teach it towards the end, that what is the order of acidity of phenols and what is the order of acidity of alcohol. Right, next reaction. Please write formation of esters. Next reaction will be esterification or formation of esters. Please write alcohols and phenols. Alcohols and phenols react with carboxylic acid acid chloride and acid anhydride to form esters. Alcohols and phenols react with carboxylic acid, acid chloride, acid anhydride to form ester. So, you should first know what are these things or these functional groups we are talking about. So, first, carboxylic acid and RCOOH. This is carboxylic acid. Acid chloride means RCOX, where X can be ClBrI. The formula will be what? CH3COCl, HCOCl, C2H5COCl. Acid anhydride means CH3CO, CH3CO. This can be written as what? CH3CO twice O. This is called as what anhydride? Acidic anhydride. Actually, I should write the formula, general formula as what? RCO twice O. This is called as what? Acid anhydride. Clear all the three? If I react this with alcohol, I will get ester. If I react this with alcohol, I will get ester. If I react this with alcohol also, I will get ester. So this is carboxylic acid. This is acid chloride. This is acid anhydride. Please write. General equation barili. Baritira general barila. In barila general equation. ArROH plus RCOOH. We are breaking what? The OH bond. So from here only this will go, and from here what will go? OH will go. Okay? So if I write this as R dash, I will get what? RCOO R dash plus H2O. Understood what I am talking about? This is okay. ARCO, please. Okay, you can here write it as ARCOOR dash plus H2O. Always remember, you should never remove from alcohol OH, because we are only specifying breaking of OH bond. Next is what? Reaction of alcohol with acetic anhydride or with acid halide. So let us make it ArROH plus R dash COCl. I am taking chloride. So what will I remove again? From here an H, from here a Cl. So I will get what? ArRCOO R dash plus HCl. Clear? Fine. Now, please write here, this reaction takes place in presence of pyridine. This reaction takes place in presence of pyridine. Fine. The first one also, you know, acidification reaction takes place in presence of acid medium or H plus ion. Fine. Now the last one, ArROH plus RCOO R-COO twice O. This also takes place in presence of what? H plus. What will I get? Now I have two R's. What will I get? One will be ArCOO R dash. Okay, see, I'll write like this: RCOO RCOO O. Fine. So one of them will remove the H from here, and what will form? RCOH. So if you put the R dash over it, one will become what? RCOH. ArRCOO R dash. So you get what? Plus R dash COOH. Is right. Understood all the three equations? I have not written whether it is AR or AR and tachna ಏನು ಮಾಡ್ತೀರಾ C6H5OH, R and tachna ಏನು ಮಾಡ್ತೀರಾ CH3OH or C2H5OH. Let us write an equation as an example. Take phenol and react it with CH3COCl. Take phenol and react it with CH3COCl. Whenever you do the reaction in CH3COCl, it has to be done in presence of what? Pyridine. So, what are we trying to tell you? Take phenol. I take phenol and I react it with what? CH3COCl in presence of pyridine. What do I get? H has to be removed from alcohol. So I get what? C6H5COO CH3 plus HCl. What is the name of this compound? Please name this compound. How are esters named? Esters are named as alkyl alkanoate. Methyl benzoate, you want to say? You want to say methyl benzoate? Methyl benzoate. Why it cannot be phenyl ethanoate? Why it cannot be phenyl ethanoate? Why do you say it is methyl benzoate? What should be the other side of the
first part is the part that connects to the oxygen.
Where it is connecting to the oxygen, it is connecting to the
CO,
carbon.
COO. It's connected to the oxygen. COOCH3.
To the C6H5. Same logic. Wow, you are telling this is connecting here. I am telling this is connecting here. What is wrong? As you are telling me it should be methyl benzoate, correct? And tell you, why can't you write this as sorry, what did I say? Phenyl ethanoate.
Because oxygen atoms are here.
Don't give me the oxygen logic, it has something else. Tell me what should be the correct name of the compound. Okay.
That is benzene.
Which is benzene?
So,
You have to be very correct. What exactly will happen?
Saying benzoate is a benzene, so
Why benzoate becomes a benzene? Why not ethanoic acid be the benzene? Fine, correct? Fine, this is the compound. What do you name this compound? You call it as acetophenone. Acetophenone. This is the aceto group. Phenol becomes what? Still you are not able to get along with this level. So I am leaving it here. Please tell me tomorrow the name of the compound. I think you are correct, but please justify your reason, because I don't want to be flying in the air telling that oxygen get attached here, carbon get attached here. Get a proper answering logic. How are esters made? That is what I am asking you. Okay? That we will talk later. Fine? Clear? Please write. Next, preparation of this is the part. Preparation of aspirin. Preparation of aspirin. If chemistry in everyday life stays and we have to study about aspirin, we studied aspirin is what? It is a drug. What drug it is? It is antipyretic as well as analgesic. Antipyretic means it brings down the temperature of the body as well as, or it brings down the fever of the body, and also it is analgesic, that means it helps to bring down the inflammation or the swelling in the body. So what is aspirin? Please write. Aspirin is acetyl salicylic acid. My salicylic spelling may be wrong, just check and write. Preparation of aspirin. CET one more question 100% varutte. Aspirin is acetyl salicylic acid. It is used both as an antipyretic, that means it brings down the temperature of the body or fever of the body, and it is also used as what? Analgesic. Okay, so we have to prepare acetyl salicylic acid or aspirin. Please write. Acetylation of salicylic acid or acylation of salicylic acid with acetic anhydride gives aspirin. This is 2-mark question in board. Very important question. So aspirin is again an ester of salicylic acid. So how do we prepare this? We use salicylic acid. Polymers, if you remember, you know salicylic acid is what? COOH and OH. Hydroxy acid is called as salicylic acid. When this is treated with CH3CO twice O in presence of always what? H plus. When I do it with carboxylic acid, H plus is required. When I do it with anhydride, H plus is required. When I do it with CH3COCl, what is required? Pyridine is required. Okay. Now from here, this H will go and one CH3COOH will go. So what will I get? I will get a compound which will have COOH, and here it will have what? OCOCH3. The ester part will come and add there, and what will I get? CH3COOH. What is this compound called as? This compound is called as aspirin. Aspirin is also called as acetyl salicylic acid. So is it clear? How do we prepare aspirin? We prepare aspirin by taking what? Salicylic acid, and I react it with what? Acetic anhydride in presence of what? H plus to get what? Aspirin or acetyl salicylic acid and ethanoic acid. Clear? So this is a very important reaction. This is all about what? Esterification. In esterification, you have to remember, when you react alcohol with acid, there should be a presence of H plus. When alcohol is reacted with acetic anhydride, there has to be a presence of H plus. But when alcohol is reacted with acetyl chloride or acyl chloride, the reaction has to be done in presence of pyridine. This is for today. Tomorrow's class, we will study cleavage of CO bond and acidity of phenols and alcohols. Kindly read till here and come.